Hi there, this is Dr. Rishi from the Learners Academy, and today we are going to talk about whole numbers. In our first video we started with the number systems, then we discussed natural numbers, and today we are going to talk about whole numbers. So whole numbers are basically natural numbers plus 0. So we have 0, 1, 2, 3, 4, 5 all the way till infinity, plus infinity for that matter. So now let's go ahead with the basic operations that we can do with whole numbers. So first we will be talking about the 4 operations that are there, that is addition, subtraction, multiplication and division, and whether these 4 operations follow the properties that are the closure property, commutative property, associative property, identity, existence of whether the identity exists or not, and inverse of that number. Now let's quickly go ahead and let's talk about the first property, that is the first operation, that is addition. So we have addition. So when we talk about addition of whole numbers, when we take 2 whole numbers and we add them, the final answer is always going to be a whole number. So say suppose we have 0 plus 4 or 5 plus 9. So this would be equal to 4, this would be equal to 14. So 0 plus 4 is 4 and 5 plus 9 is 14. 4 and 14 both are whole numbers. So therefore we would say that whole numbers follow, they follow closure property. So the addition of whole numbers follows a closure property. So the addition of whole numbers follows closure property. Now let's see what happens when we add them in a different manner. So say suppose I have 5 plus 1, it is 6, and 1 plus 5 is again 6. So if we change the order, it should not make a lot of difference, or it does not make a lot of it does not make any difference. So from this we can conclude that addition of whole numbers follows the commutative property as well. So we can say addition of whole numbers follow commutative property. Now let's go ahead to the next property that is there, that is associative property, wherein we take say we have 0 plus 1 plus 5 is going to be equal to 1 plus 5, so it's going to be equal to 6, and 0 plus 1 plus 5 again would be 0 plus 6, so that is 6. So from these two we can conclude that even if we group whole numbers separately and add them, the final answer would still remain the same. This property tells us that this example tells us that whole numbers, addition of whole numbers follows associative property as well. So we can say it follows associative property. Now let us go ahead with identity. So when we discussed about natural numbers, we said that there is no identity in additive identity in natural numbers because 0 was not included. Now 0 is included in whole numbers, so we consider 0 as the additive identity, because we know that 1 plus 0 is equal to 0 plus 1 is equal to 1, or 10 plus 0 is equal to 0 plus 10 is equal to 10, which basically tells us that the identity of the additive identity of whole numbers exists, which tells us that the additive identity of whole numbers exists, and that identity is 0. So we can say that identity exists for whole numbers, and this identity is equal to 0. Now, though the identity exists, there are no inverses, additive inverses, because additive inverses are all negative numbers, and since negative numbers are not included in set of whole numbers, we say that the additive inverses don't exist for whole numbers. They do exist, but they are in integers, so we do not consider them in the set of whole numbers. So this was about addition of whole numbers. So now let us go ahead and let us talk about subtraction, what happens when we subtract two whole numbers. Now let us talk about subtraction of whole numbers. So when we subtract two whole numbers, it is not necessary that the final answer is going to be a whole number. So we can have 3 minus 2 is 1. However, 2 minus 3 will be minus 1, and minus 1 is not in whole numbers. So we'd say that subtraction does not follow the closure property. So subtraction does not follow closure property. Now, subtraction is not following closure property. Now let us see whether subtraction is commutative or not. From the same example, we can see that if we replace the values, that is, instead of having 3 minus 2, we write 2 minus 3, the final answer is not equal. This answer was equal when we talked about addition. However, in subtraction, the answer is not equal, so we would say that subtraction also does not follow commutative property. So we'd say that it does not follow commutative property. Then the next thing that we have is whether it follows associative property or not. So let us see whether it would follow associative property or not. Now since so let's have it as say 5 minus 4 minus 3. First we do the subtraction between these two. So this would be 5 minus 4 minus 3, so that is 1. So this gives me 4, and then I have 5 minus 4 minus 3, so that gives me, so 5 minus 4 is 1, so it is 1 minus 3, so that is minus 2. So as we can see, we get two different numbers after we just interchange the groups, with which we can conclude that subtraction of natural numbers does not follow associative property. So we can say that it does not follow associative property. Now, do we have a subtractive identity? So yes, 0 is a subtractive identity. So if 0 is subtracted from any number, the final answer would not change. So we can call 0 as a subtractive identity. So subtractive identity exists, and inverses also are not going to exist, because the inverses of any number, the subtractive inverses would lie in the group of integers, so they would not exist. So this was about subtraction of natural numbers. Now let us go ahead and let us talk about multiplication of natural numbers. Now when we multiply two natural numbers, say 3 multiplied by 4, we get the answer as 12, which is a natural number as well. Even if we multiply say 5 by 0, the final answer is a natural number. So even if you have 5 multiplied by 0, the answer is 0, which is again a natural number. So we can say that multiplication follows closure property. So we can say that it follows closure property. Now what happens if we change the order? Again, it doesn't matter at all. So 5 multiplied by 3 is 15 and 3 multiplied by 5 is 15 as well. So from this we can easily conclude that when we take two whole numbers and we multiply them, then the order does not matter, with which we can conclude that it follows commutative property. Now again, let's talk about associativity or the associative property. In associative property, we have, say, we'll have 3 multiplied by 4 multiplied by 5. We group them separately and multiply them out. The answer, so let's make it as, say, 3 multiplied by, so let us have in associative property, let us have 3 multiplied by 0 multiplied by 5, then that would be 3 multiplied by 0, so that is 0, and 3 multiplied by 0 multiplied by 5, so that again would be 0 multiplied by 5, so that is 0. So in both the cases we can see that the answer is exactly same, which would tell us that multiplication of whole numbers follows associative property. So you can say that it follows associative property. Now, does a multiplicative inverse exist? It does, but not in a set of whole numbers. So it would be a fraction, so it would exist in some other part, but as far as only whole numbers are considered, multiplicative inverse does not exist. However, multiplicative identity exists and it is equal to 1, just like the natural numbers. Now let us talk about division of natural numbers. Now this is slightly tricky because when we talk about natural numbers, a 0 also is included. So first, if we divide, say, 1 divided by 5, then that would become 1 by 5, which is 0.2, which is not in the set of set of whole numbers. However, and also if we have, say, 5 divided by 0, then that would not be defined. So I can either write it as not defined or as infinity, because I cannot do a division by the number 0. That's a problematic thing. So with both of this we can say that, the division of whole numbers does not follow the closure property. So we can say that it does not follow the closure property. Not only that, but sometimes if we divide by 0, the value may not exist at all. Then if we say, what happens if we divide it the other way around? Say if we have 6 divided by 2, I'll get it as 3, but 3 divided by 2 divided by 6 would give me a 1 by 3, which again won't be included in the set of whole numbers. So I would say that division is also not commutative or does not follow commutative property. Now what happens if we do it in groups? Say suppose we have 3 numbers and we are dividing them, say, so we have 3 divided by 2 divided by 4. Now if we group them like this, I'd get it as 3 divided by 1 by 2, so that would be 3 multiplied by 2, or it would be equal to 6. and 3 divided by 2 divided by 4. I group it like this, it would be 3 divided by 2. So it would be 3 divided by 2 would be 3 upon 2 divided by 4. So that would be 3 upon 2 multiplied by 1 by 4. So that's 3 by 8. So if you see, both of them are not same, which would mean that division does not follow associative property. So let us write it here. It does not follow associative property. Now, does the identity exist? So yes, identity does exist. The identity is 1. So if you divide any number by 1, the final answer would be equal to the number that we have. So we would say that the identity would exist, and that would be 1. Okay. Now, does the inverse exist? So no, inverse does not exist for the inverse does not exist in division, because that would become a fraction, and we are not including fractions in the whole numbers. If you found this video helpful, please give us a thumbs up. Please share this video with your fellow friends and fellow students who would need this, and also do subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.